Welcome to Office Hours, everybody. We've given it the standard 2-minute delay. Today we're going to be talking about, once again, some cool topics. Today we'll be talking about building smartos presented by Dan McDonald. If you have questions, go ahead and ask them in the chat or ask them over the voice channel. But let's have Dan present. Dan, go ahead and take it away.
Okay, hello everybody. Small crowd today. That's all right. So I have 3 terminal windows over here. Everybody can see them okay? I will assume silence is assent. Oh, hey, beautiful. Look at that. Okay. No. I've got the chat. Oh, okay, beautiful. Thank you, Jasper. Okay, yeah. No. It's my window. There we go. Okay, I needed my window wide enough to see the chat and who's on board at the same time. Okay, that's great. Now there are 3 windows over here. This one that I just highlighted a little has finished smartos live build. Successful smartos live build. This one over here, highlighting, has pulled smartos live and run configure already. I'll use that for another part of this. And then finally, this window over here has not done anything yet for smartos live. And you have, waiting for me to hit return, a git clone. So I would highly recommend to anybody here to read the documentation at some point. Hold on, I want to make sure I'm going to paste a URL as soon as I can find it on my browser. There we go. Right there. And I'm going to paste it in the chat. Boom. That document is pretty good, actually. The building smartos section of it is pretty good. So we are not going to discuss in detail today what a build zone is supposed to look like as far as its configuration goes. I will show briefly what one looks like, but I'm not going to lead with that right now. But basically, once you have a zone in either standalone smartos or on a Trtion compute node that has all of the extra tweaks you need added to make sure that it can build, the first thing you want to do is git clone smartos live. Boom. So the bottom left window, there it is. Yay, it's done. smartos live. And so that is now ready to run configure if we want. Now we're not going to run configure yet because I'm going to jump to the end now where this smartos live has completed its build. Now I'm going to list a series of files that the build creates, and I'm going to do them in time order. They're all stamps. And they start from the oldest one, pre-flight, which literally is what you think it is. It just does a reality check really quickly. Right now, the only thing it does is it makes sure that OpenSSL 3 is available. Now, the next stamp is the strap stamp. Now, that's interesting because the first compilation phase we do is bootstrapping the tools you need to build the rest of smartos. And there is normally, if you're not messing around with the illumos extra repo, we'll talk about the smartos 8 momentarily. ls-lt proto.strap. What the strap stamp will do is actually download, or if you haven't already downloaded it, a pointer to a cached and already built bootstrapped set of tools. Now I'm going to come over here to this one, and I'm going to do gmake 0 strap stamp. And this is going to take a very short amount of time. Boom. Well, look at that. It's already there. It discovered that this hash, by the way, is the git commit hash for illumos extra. And it discovered that I did not do any changes to it, so it will just instead link this. If we were making changes to illumos extra, this would take over an hour to build. So I've just trimmed an hour off the build time by having a strapped stamp there. The first time you build smartos, it will find and try to download a strap if it has a matching hash. Now, in my case over here on my smartos 2 build 2 machine zone, it already had it because I build smartos there a lot. So that's what it's there for. So, but basically, smartos builds go through all of these stages, all of these stamps. The one after it is illumos. It's exactly what you think it is. It builds illumos joint. The one after that is extra. It builds illumos extra. I'm going to put in the chat the 8 smartos repos. smartos-live, illumos joint, illumos extra, illumos kvm, illumos kvm command, mdata-client. What am I on right now? 6. Hold on. Oh yeah, no, agent. It might be SDC urge agent. Actually, I can't remember what it's called. And then kaboomd. Those 8 repositories I just put on the chat are all one needs to make smartos, and all of those, and the 7 that aren't smartos live will get pulled over by running configure, which I did down here in this one. And if you look, you will see under projects. Oops, wait a minute. Did I run configure? No, I haven't run configure yet. I'm so sorry. Let's run configure. And it is going to go through, and I will talk while this runs, but it is going to clone all of the other repositories that are needed, and they will all go into that projects directory that I highlighted over there.
Yeah, and those projects are listed in the default .configure-projects file.
Oh yeah, let's take a look at that. Yes.
So if you ever don't remember, they're in there.
There they are.
Anything that we add in the future will go in there. So that's where you'll be able to find them. So this is not something you need to keep in your memory because it's always right there.
The only reason, and it's funny you mentioned configure projects. Thank you, Brian, because there's one thing you can do. I'm not going to actually run configure again, but if you choose to make changes.
So this is something you would do if
you're in development.
Yeah, if you're wanting to contribute something to smartos, when you do your build, you change this file to point at your copy of whatever that repo is, and you run a build, make sure that that works before you do the pull request.
And we have a brilliant example that I'm going to be using today. But I can't do it on this one because I already did it. I already started configure down here. Now, just because you've made a change doesn't mean you have to build the whole thing over from scratch. But we are going to look at branch Trtion 2388 in Toitate's mdata-client copy. So I'm just going to write out that. I'm going to remove this file temporarily. Now, as you look back over here at the stamps, illumos extra, live source basically is anything that's local to smartos live. Oh, wow, there's a lot of stuff in there. You may recognize a few things like FSS stat, disk layout, PIATM, ZoneMon. These are all things that are in the smartos live repo itself. So let me list those stamps out again. Whoops. There we go. So that's covered by the live source stamp target. And then there's kaboomd, kvm command, the user space component of kvm, mdata-client, which we're going to actually muck with, and then the agent, and then followed by a few other post-processing steps And once you get to DevPro, whose sole purpose in life is to install the old C++ runtime from the Sun DevPro compilers for applications that still use it, then you have smartos built. So if you want to change a component on an otherwise built smartos, the first thing you do is you remove the stamp. And it's going to be the subdir mdata-client stamp. Yes. Why? Because we're going to go into the projects. And you can see DevPro is something that just gets detarred. Illumos Extra is from GitHub. Illumos is basically a child of Illumos Joint. And then there's a local subdirectory, which has all of the other repositories. Kaboomd, that is for secure, that is for encrypted ZFS, for encrypted zones ZFS file systems. The KVM command, the user space portion of KVM, KVM, the kernel space portion of KVM, mdata-client, which is something that is installed into native zones, so it can talk mdata with the global zone. And the agent is also something that runs in the global zone as well. That is the top agent of all of the other agents. But let's go into mdata-client. Git status, it's up to date. Now you'll notice over there, I forgot to do it again, but I'm going to update this with a different HVS, with a different mdata, with one that's got a work in progress under code review right now. It is in Jonas's, aka Toitate's. Oh. And he has a branch for it, Trtion 2388. This basically changes the name of the mdata client from Joyent mdata client to Trtion mdata client because we're no longer part of Joyent. So let's do that. Wow, that was quick. We had some changes. That was quick too. If I do a git status now, you'll see that I'm ahead of the master repository by 4 commits. Git log minus stat. And you can see he put in a copyright update because I told him he had to do that. He had some other code review comments that Brian and I pointed out, and he took care of those very nicely. He's not here today. And of course, his initial commit, and this line, along with reviewed by lines, will be what lands in mdata client upstream in the Trtion Data Center repository. So that's here. Great. Now the first thing we need to do is, I had removed that stamp earlier. I am now going to make it. And before I hit return, we're going to go down here and you see that, oh, look, the configure finished. And you'll notice it did some package source things too. Any packages that you require to build smartos, except for Git, because you can't do a Git clone of smartos-live without Git, will be installed for you by the gmake, by the configure script. Oh, you will, however, and this is in the instructions, need to make sure security auth adder. Wait, no, hold on. I can't remember where that goes off the top of my head. Whoops. That's it. It's central user adder. Basically, this is a fancy way of saying that you need to be able to invoke the pfexec command and have it give you all of the privileges you need to be root, basically. Touch, etc. foo, lt, etc. foo. Oh, look, it's root. So basically, but yeah, I can't do that, but I can do that as pfexec. All right, anyway, so once you have a properly configured build zone, it will do all of this stuff for you, even stuff that requires privilege, because it will just invoke pfexec where appropriate. So now that we have this changed mdata client that Jonas has fixed for us, let's see if it builds. So we're just going to make the stamp. Boom. Well, that was quick. It seemed to have worked. Look at that. Did a bunch of installs. Given that the differences we're seeing were a bunch of man pages and some packaging things, this was pretty quick. And see, look, it did all of the man page installations as you'd expect. If I type in gmake 0 mdata-client stamp again, it'll have a lot less output because it's already up to date. Now, if I do gmake live, hold on, let's list those stamps again. Okay, now that is newer. So anything that follows it is going to have to get rebuilt. Gmake 0, let's just gmake live. And this might run for a little bit while we keep talking, but it's going to build all the stamps that come after mdata-client. Oh, not as many as you'd think. And it's already starting to build the platform image, as you can see by that line right there. And it's going through, and some of the stuff it's doing requires both root privilege and additional zone privileges we don't normally give to a zone. Let's take a look at one of those. Root at Shemp. Yes. Sorry, I know that. Okay. vmadm list smartos build rep. Okay. vmadm get grep file. Okay. One thing you'll need to make darn sure that is added into your vmadm configuration, and on a Trtion compute node, you have to do this by hand as root at the global zone of the compute node, is to add that fs allowed in there, where you grant the zone permission to muck around with UFS, PCFS, and tempfs file systems, which is important because we build all of those as part of building Trtion, including the platform image, and including you can do gmake ISO, and that will generate an ISO image after it rebuilds the platform image one more time. But after this, you will see, and after this one builds, I'll show the output directories that get generated by this build. Yes. Oh, also yeah. Okay. So there's that. But basically, so that's going to run right now. Does anybody have any questions thus far until we get to the actual results of the build? Very quiet.
Two things.
Go ahead.
What is the happening in Strap build exactly? Might be a dumb question, but
No, it's not a dumb question. It is building a subset of Illumos Extra. I'm going to change into it here, actually. So we're going to look at the make file in Illumos Extra, and you will see that there is targets defined for strap builds, and they are inside basically the makefile equivalent of ifdef blocks. And you will notice down here that it makes these files, that it makes these parts of Illumos Extra before it builds anything else on the system using whatever is available locally. Basically, the compilers here, the compilers for building strap are from package source. We actually build the compiler in strap that we will use to build the rest of smartos, starting with Illumos. So it'll build the C preprocessor, bzip2, a couple of libraries, the platform node.js, which is really old, but that's okay because we're self-contained. NSPR, that's a Netscape portable runtime, and it contains some security functions. Two versions of OpenSSL. LDAP uses that. Thank you. Two versions of OpenSSL. Some of our other components have not migrated off OpenSSL 1 yet. Everything else is using OpenSSL 3 now. And of course, Perl, as well as any compilers we need.
thanks.
Yeah. So
Yep.
Strap in this case is like Bootstrap. These are the things that you need in order to build smartos or in order to build Illumos, right? And so you can either use package source to build all these things and then build Illumos, Or what we do is anytime something in illumos extra changes, we will rebuild what's called the strap cache
Yeah.
and store that in Manta. And so if
That's what
there's
gets downloaded.
if there's one in Manta that matches what you're trying to build, then instead of having to build all of that yourself, it will download it from Manta and just unpack it and use it because we've already created it for you.
And it will cache it in your opt file system. See what I'm highlighting right there. And if you go look at proto.strap itself, you will see some things. You will see proto.strap opt. And look, there's OpenSSL 1.x. What else do we have here? We have user, we have GCC. We have both GCC 10 and GCC 7. Although there's a dirty little secret. If you configure saying GCC 7 should be your default compiler, it will actually rebuild the strap because it won't be using 10. And the whether to use strap or not is highly dependent on having the primary compiler being the primary compiler. But yes, there's GCC 10 in the downloaded strap.
Yeah. And the reason that all of this happens is a really long explanation that I'm not going to get fully into, but I will point you towards Ken Thompson's Reflections on Trusting Trust and how do you know your GCC compiler is safe to use and is not compromised. So we compile the compiler used to compile the system as part of compiling the system.
Yes.
And so that's the bootstrap is this is all the stuff that we need in order to actually do the build, and we don't trust anything external, not because we distrust it, but we want to have like a line of integrity that we can count on, that we ourselves are responsible for.
Yeah. And the compiler we use to build the bootstrap comes from user local bin, which is package source. And that one is set to 10.3 right now. I think we need to make sure our compiler is annotated with -il because it does have the illumos patches in it. Projects, illumos extra, GC10. Now I can spell. There we go. Yeah. And in fact, this tarball right here is from illumos. This is the same tarball that all of the other illumoses use for their version of GCC. We patch GCC so it can make things like dtrace a lot easier, because GCC by default will optimize certain things the way that it really shouldn't for maximum observability. So we want to maintain the conceptual integrity of what we have for illumos observability, and that's true across all distros. So, so our build finished over here, and once the build is done, you will see some output directories, output ISO and output. Let's look at output ISO first because it's going to be very small. There's your ISO image. In production, when we cut a biweekly release, that platform.whatever.iso gets renamed, uploaded to Manta, and becomes the downloadable smartos ISO that you can download, or if you're using mdatom, it will seek it out and download it for updating. The normal output directory has a few things in it. It has the classic platform image that those of you who run Trtion or use mdatom to just update the platform without updating loader and the other boot bits are there. It has the boot bits in it. There's an RFE out there that lets mdatom eat the platform TGZ and the boot TGZ, and everything gets upgraded. Haven't done that yet. The build stamp is there. More output build stamp. There it is. That gets created. There are other targets you can make. We, for example, have to generate these tests, and the automated procedures, the automated Jenkins jobs do that too, which will get uploaded. And oh, look, there is the tests tarball. which we then turn around and use on a installed from scratch standalone smartos machine to make sure we haven't regressed. So it's pretty straightforward and thought out build system here. The only tricky part is if you're going to make changes to illumos, there's a couple of things you can do. If you want to just change one small command, you'll notice that there's an illumos.shell file here. This is an env file for nightly. User source tools scripts nightly. And if you want, and what you can do is you can run nightly again all by itself, which will install everything into the proto area. This proto area is what is consulted when you build platform image TGZ files, ISOs, anything else. This is laid out exactly like your installed system is. User bin cat. Whoops, hold on. Sorry, it would help if I type proto beforehand. There it is. Yep. The different build dates are there, but they're pretty much the same file. So, but yes, so everything is installed into that proto area. If you are messing with something in illumos and you do, I don't know how many people are familiar with building components in illumos. I've blogged about this a long time ago. I probably need to update it for beyond the world of OI and Omni, but you can just run the install inside illumos here in smartos live in the projects directory, and then you can run gmake ISO, gmake live, or gmake ISO again, and it will actually be updated because it will actually change something in proto. Let's try that actually. CD projects, illumos, user source, man. Let's do that. That'll actually be easy. Man 8. Just change the date on here really quickly. Okay, fair enough. Now, illumos is funny. You need to have a bunch of environment variables set. And if you don't run the nightly script, you can run user source tools, scripts, build env, and that illumos.sh file I was talking about is there. Boom. Now, I have a special hack in my C# to let me know that I'm under the influence of build env. It's got the big old WS there. So if I just do gmake install, you'll notice it just added my changes to ZFS8 into the proto area. And you can check that really quickly. Man ZFS. Let's pipe that into tail so you can see the date. But then if I do man -m smartos live proto user share man ZFS, pipe that into tail. Oh yeah, look, there's my change date. But yes, get status. Let's revert that because I really don't want to update the, oh, whoops, that's actually bad. Get diff. Get status on a built illumos system will go through a lot and discover a lot of unused files. Get checkout -cfs.8. Okay, and now get diff shows nothing. And in fact, if I make install again, it just did that, and then man on the proto area, and it's back to where it is. There's a whole other blog post I need to do on building small in smartOS, where if you're making tiny changes, you can build the entire system default and then make your tiny changes, and without much time doing it. Building the whole of smartOS does take time. On my build, these build zones all have older but decent hardware attached to them, and with a cached Bootstrap, I can build in less than 70 minutes. If I have to build Bootstrap, it will take 2 hours and 20 minutes. So yeah, that's a lot more. Yeah, an hour and 10 versus 2 hours and 20. So, but yeah, decent as in a lot of cores. Actually, Jasper, I prefer faster cores to wider cores, although there are newer modern machines with wide amounts of cores that actually perform well too. We have experimented with these in the MNX cloud that we use for our Jenkins agents. My rule of thumb to budding illumos developers is to go with faster cores and trade off for faster cores instead of more of them. But that advice is less applicable on more modern hardware. So, as always, your mileage may vary. The other thing you want to make sure of is that the number of jobs you do is applicable to the amount of cores and the speed of cores you have available to you as well. We actually in Nightly do a better job of that in smartOS now, because we actually use mdata to figure out how much CPU we have at our disposal. It also means making sure your zone is properly sized to, and last week's talk was about this. Allocating the proper CPU shares to your zones based on how many virtual CPUs and it applies to native zones as well, at least in the CPU shares department. So Brian talked about this last week, and that lesson is very applicable to properly configuring your build zone, which will be native.
Yeah. You can speed up the build some by increasing the number of jobs and parallelizing some of the builds, but some things are necessarily blocked on other things, and you can't just infinitely scale wide when you're doing a platform build.
Yeah.
So scaling wide can help to some degree, but you're going to get much better performance going moderately wide, like 8 to 16 jobs tops, but
8
then
to 16
scaling
cores
faster.
Yeah.
Yes,
Yeah,
scaling
8 to 6
faster CPUs will get more benefit at that point.
Yeah, I recommend 8 to 16 cores, and what'll happen is, hold on, let's look at the build logs from the smartos live. I did project illumos log latest. Let's look at the mail message really quickly. Yes, so 26.
So that was the most jobs it had in progress at one time.
Yep. And I have 24 cores that this zone uses now. Yeah, I give my build zones all the resources, which means if I'm running hardware VM if I'm running anything stressful or even not stressful on a hardware VM, it might complain about CPU stalls and stuff, but that's because, well, hey, I'm building illumos, so tough. But yeah, basically the nightly build script will take the number of cores you have and add 2 to them.
Okay. So that's not actually a record of the number of jobs that were active. That's just the cap.
That's the cap. Yep. Right there.
Okay.
Yep. That comes in your mail message.
Yeah.
So yeah, and anybody here who's engaged with Illumos knows that you have to submit a mail message as part of your request to integrate. So yeah. Jasper, I'm pretty sure you've done it at least once or twice and stuff, and yeah. So yeah. But yeah, that's how you build. That's how the keys to remembering how to build smartOS are. It's like it generates these stamps in order. And if you're altering something for a given stamp, whether it's mdata or whether it's illumos, you will have to remove that stamp, and then you can do gmake live again. And it will pick up where you left off on that, but sometimes that might be bigger. And then in cases where you want to really build something small, you might be able to build in the component you're building in, and as long as it generates its output to the proto area, then you can just jump back up and do gmake live, and gmake live always will suck everything in from the proto area from scratch and start it over again. Gmake live will never say, you already did it. It will always suck everything in from the proto area again. So, any questions? I think I've said my piece here. Any more questions, I'm happy to answer them. And if not about building smartOS, we're here for any other office hours type questions too, because at the end of the day, that's what this is about.
So maybe not entirely unrelated and maybe a bit out of scope, but
Oh, go ahead.
how does the full Triton image factor in this, which is
Okay.
basically
Brian, you're going to have to make sure No. It's a good question. Here's what happens. For Triton, the big target we release is, you have when you're on a deployed and running Triton, you're just upgrading these components one at a time. And what you're updating in Triton is you're getting, let me go to this one window and go back to the beginning here, ls output. Now, if you're on a running Triton, the only thing you are doing is you are pulling this. SDC Atom platform deals with these TGZ platform files. That's all you're doing. That's for a running Triton. Now, if you're not on a running Triton, if you're starting from scratch, we have this component called SDC headnode, and it will generate either a USB key image or an ISO installer, and that will build based on this platform plus anything supplemental you need to install a headnode. But the unit that Triton deals with almost exclusively for smartOS is that platform. Now, Brian, correct me if I'm wrong. If I need to update loader on on the headnode, I'm going to need to do update GZ tools. Is that right?
Yes.
Okay, thank you. And that update GZ tools, by the way, will eat one of those, as well as other global zone tools.
Yeah. So in the chat, I'm going to drop the link to our latest release on our Jenkins instance. So if you take a look at that, these are all of the components that get built as part of Triton and Manta for one release. Okay. So the platform, which the project, they're all named after the GitHub repo. So the project in Jenkins is going to be called smartos Live. So that's one component of it. When we build a Triton image, we need to build all of the SDC and Triton components that go onto the headnode image, and which of those is listed in the SDC headnode repo. Okay, so all of those need to be built, and then the platform image needs to be built, and then SDC headnode builds and will pull in all of the build artifacts from all of those different projects and add all of that to the USB image. Okay. Now, a Triton USB image is basically the platform image and all the images that are used during installation time. So after you install your Triton headnode, the images directory that has all of SDC vmap, SDC mjpi, you don't need any of those after install time because they get installed into the local running data center and they're never read off the USB again. So if you want to make room on your USB, that's something easy to dump. It's about 5 gigs of data that you can dump there, giving you a ton of space to hold like all kinds of platform images on on the USB key.
Also, those I believe are also stored and can be removed in $boot pool /boot if you do a disk booting Triton headnode.
Yeah. Yeah, or the boot media, whether that's actually a physical USB or if you're using a data set on your Z pool.
It can, any Z pool. Yeah. Bootable pools do not have to be zones. They can be, but they don't have to be. Says the guy who runs a head node. Says the guy who runs a head node with a distinct bootable pool versus a distinct zones pool. So yeah.
So that's kind of a very short overview of the Triton build process. Does that answer your question? Do you have additional questions around that?
No, that kind of answers the question. Pretty interesting, I think.
Okay, good, great.
Yeah, I put the number of repos. I talked about the smartos 8 repos, but yeah, the Triton and Manta are 76, and so I've got all that there. I put all that into the chat. But yes, coming next week, we will be building all of those 76 repos because next week is not just a smartos release; it is also a Triton one.
Yeah, and so we do our branch Wednesday or Thursday midnight UTC time.
No earlier than. Sometimes it's later.
Sometimes later, but no earlier than midnight UTC on Thursdays, because we want the timestamp for everything to be on Thursday, because that's like our sprint boundaries, and so it aligns things nicely that way. So come next Thursday, we'll be adding in a new tab for release 0601. Okay, so release 2023-0601. And if you get there in time, you can actually watch all of those things build in real time. And you can see, if there's any failures and we've got to go rebuild something, sometimes that happens. So you can actually like watch in real time as the system is built. And there's a couple of things where there's like there's dependency issues because we kick off all the builds at the same time. And so like headnode is just going to fail right away because the components that it needs to assemble the USB image aren't built yet.
Headnode doesn't actually fail. Headnode when headnode is automatically kicked off, it only builds the check target. Same with smartos Live.
Right.
Same with smartos Live. But there are other repos that do have this problem.
Yeah.
The big one is agents installer.
Yeah, agents installer. Because all of the individual agents haven't been built yet. And so those all have to finish building, and then we re-kick off the agents installer build.
Yeah.
And then once that's finished and everything else is finished, then we kick off the headnode one, and it assembles the final image. And then we test it throughout Thursday, and we do the release announcement on Fridays.
Yep. So yes, there's good timing for your question and good timing for your question relative to the release cycle right now. So thank you, Jasper.
Yeah.
Super helpful. Really. Yeah. Anyone else got anything? Very silent. A little worrisome, but that's okay.
If nobody has any questions, then I'm kind of curious as to why you made the USB setup the way it is. I'm not judging in that sense, but I had to design a similar thing based on FreeBSD. And I also made some choices, just like you made some choices. And I'm just curious why it ended up like booting off the USB and then basically ditching the USB and moving forward from the disks in the machine itself instead of, for example, staying on the USB or loading parts in RAM disk or all those kind of choices you can make.
Okay, so
go ahead, Brian.
It's the fundamental model of smartos hasn't changed. Even when you're booting off the Z pool, it's still using a RAM disk. The boot pool, whatever pool it is, is only used during the boot process to load those artifacts into memory. And once they're loaded into memory, it doesn't use that boot pool anymore.
You can export it if you want.
Yeah. And so
yeah.
the reason that smartos runs from a RAM disk, there's a lot of history to it, but to kind of like as succinctly as possible run through the history here. One of the original reasons to do it was to dedicate all disk space to tenants. So there wasn't any space used up by the operating system. And Trtion SDC, Trtion was called Smart Data Center before it was renamed to Trtion. So SDC always ran Pixie booting. So as you may know, a lot of the people that designed smartos and smartdc in its very nascent forms were Sun alumni. And they really liked the sparse root zone model, which is what joint brand zones are, or native brand zones, as we sometimes call them. Like the native zones are sparse root. They really liked that model. They really liked the model of being able to boot an entire network of machines completely diskless, to have a single control point where you can assign the operating system to be used by any computer. And using a specific, like, cohesive platform image that's the entire operating system has a lot of advantages. The networking world has used this forever, basically. You download a firmware image and you drop it on your switch, and there's a config file on the switch, and everything about the behavior of your switch or your router or whatever is determined by your config file. Some advantages of that: your operating system can't get owned. A virus that comes in can't rewrite parts of the file system because there's no file system there. It's not persistent. In smartos, the user directory is mounted read-only, so you can't modify it even if you wanted to. Bin and sbin are read-write, but they only exist on the RAM disk. As soon as you reboot to a platform image, you're running clean. So that's a huge advantage. Whenever you want to upgrade, you just select your new platform image and you reboot. If something goes wrong, you just select your old platform image and you reboot. So operating system upgrades and downgrades are completely trivial.
Modulo flag days.
Yeah, I mean there's occasionally something like that, where a new Z pool feature is added, and so if you boot to an older platform image that doesn't understand that feature, then it can't use that feature. But other than that, that needs something like you need to explicitly enable those features. So you're usually not going to be hit by something like that. It's extremely rare that you run into a situation where you boot to a new platform image and it just doesn't work. And even if you run into that situation and you have a problem, you can almost certainly go back. It's almost guaranteed that going back to an older platform image will always work no matter what.
It's been very handy.
The previous one that you used. So in a nutshell, those are the reasons for it. Dedicating all space to tenants, being able to pixie boot diskless the entire fleet. Upgrades and downgrades are trivial. You just assign the platform and reboot. And that model of an immutable OS image is actually spreading throughout the industry. So that's something that was possible before. It was pioneered originally in like networking hardware or appliance devices, and like smartOS and Joyent brought that to general purpose computing. We were the first ones to do that. And that has been picked up by a couple of different Linux distributions. So like there's Flatcar and there's CoreOS do that. And macOS now has Immutable OS Images. So like that model of having an Immutable OS is spreading through the industry, and that's an innovation that came here first. Like we brought that to general compute. Nobody had ever done that before. Nobody had ever thought like, yeah, this would be a great idea to do, and then just do it at large scale. So yeah, I mean, there has been ways to configure. Jasper says Fedora has tried to make diskless OS forever. There has always been ways to like take an OS and like put the image on NFS and have Pixie boot it and all of that. But that was not the standard way that things worked. Fedora or Solaris, when you go to the website, here's how to install it. They don't tell you to boot it over the network. They tell you to install it to disk. smartOS was the first general purpose operating system that said, no, look, this is a diskless operating system. You should be running this diskless. You can boot from a USB image. You can boot from an ISO. You can boot from a Pixie. But you're booting an immutable read-only image that will only exist in RAM post-boot time.
Yep.
So, and now like we can see that being picked up by more operating systems. I'm particularly excited about that model being used in macOS. I really like it. I think it's pretty cool.
So, you'll notice the RAM disk is. I just went to a that I have. It's actually a VMware VM, but yeah, slash is RAM disk, and Brian said user was read-only. It's actually mounted a TGZ file. Now I can touch Kibi. That's fine, but it's only on the RAM disk, so that's a big deal. Touch user Kibi. Can't do it.
Yeah. So yeah, like Jasper says, it was mostly novelties. Yeah. Like there were installations like in a university network or something like that where they're gonna reboot the whole computer lab in between classes to make sure that they've got a pristine running system for the next class that comes in. And that kind of thing was possible. But smartOS was the first one to say like, no, that's how we always do it.
Okay, cool. We are approaching the end of our hour. Jasper, these were some great questions. Thanks for asking them. I hope it looks like, according to chat, we answered them okay. That's good. Appreciate that. Anybody else have anything before we call it?
Next week, we may be talking about contributing to Trtion. And so it's interesting that this building smartOS will be contextual to that topic as well.
Yep. And then get proper review. Document your tests and get proper review. That is the illumos way. That is the smartOS and Trtion way. And the illumos way inherited from the old days of Sun, from Solaris development.
Yeah, you don't just get to throw things in there. Of course, you can test your own changes,
absolutely.
But
We encourage that. Yeah.
But you don't, no. I'm just saying you don't just get to be like, I want to put this in there.
Exactly.
Accept it, right? We have
we do.
Review process.
All right. I guess with that, thank you everybody. And we have another one of these in 2 weeks, and there's a good chance it'll be about contribution. Okay. Thank you everybody.
Yeah, thank you. And if you have questions or suggestions, put them on IRC or Discord, anywhere else that you can find us.
We're available lots of places. We're here in Discord. We're on IRC. We're you can find us. All right. Thanks, everybody. Yep.
Thanks.
All right. Have fun, everybody. Bye.